look, all of a sudden there's an image file you can't view. Are you going to think out of those 500, the one that's corrupted, are you going to go find another product to go view it? I'm not sure. And so denial of service might actually be an interesting thing for people. It's certainly also an interesting thing because we've gotten some excuses from the vendors like, oh, well, that denial of service can be fixed by taking a hex editor to the drive and stuff. If Officer Bob was that handy with a hex editor, these products wouldn't have to exist, right? And that's not an insult to Officer Bob, but Officer Bob is a trained law enforcement officer. He knows about the law. He knows about evidence. He knows how to collect it. He doesn't have to know what exactly which bits do what within the NTFS file structure. And so something to think about is what the impact is. And if we're not talking about the impact, Chris will later. So what are the techniques for finding bugs? One thing you can do is go do random fuzzing, right? This is not really a sexy thing. I mean, people have been talking about fuzzing for many, many years. But it turns out that just randomly fuzzing files and feeding them to forensic software is very, very effective in causing lots of crashes. So effective that it's almost certainly happening on a day-to-day basis to people who are just using these products and opening up corrupted hard drives, which is supported by if you go read the user forums for some of these products, and that you see that every day there's about a dozen different postings, my product just crashed. Here's a screenshot. The robustness issues and parsing these things and looking at files have a real effect on people even who aren't being intentionally attacked. I think there is an interesting issue of if people start finding exploits that run against these start releasing exploits that run against this software, whether or not if you're an examiner and you do your examination and the product crashes 15 times, whether or not that's going to be something interesting the defense attorney asks you about, right? How many times did your product crash? Oh, about 15 times or so. Did you write down when it happened? No. Did you write down EIP? No. Did you save dumps? No. It just crashes all the time, right? That might be an interesting conversation to have. So, and then fuzzing's good, but in things like file systems, they have a very definite format, and there's lots of things that are kind of obvious to a human being might be bad. Things like if I have a very deeply nested directory, if I have loops in my directory, there's lots of little games you might want to play. And it turns out this is also a very effective way of finding bugs. Just think of if I had to write an NTFS parser, I had to write an ext3 parser, what mistake would I make? And then try to find that mistake, try to express it. Just pushing the corner cases of the file systems. So Chris, you want to start talking about this?
Hopefully my microphone is working. Am I cool? Okay, so we used a fuzzer called FileP, which Jesse from ISAC invented. And here we just list some of the mutations that it does, which we use to cause various types of trouble. And it's pretty much, they're mostly pretty simple, and the notable thing is that they're completely blind to the specifics of any data format. We just swap a byte with null, increment a byte, make up a funny 32-bit word and drive it around in the file for a while, stuff like that. And it turns out that there's probably deeper and more interesting bugs present, but this got us plenty of stuff. So simple is certainly effective. Now FileP offers more mutator functions, but we had to take some out because, as it says, things like file systems depend on specific alignment of specifically sized objects. And for example, if you fuzzed an image by just taking a 32-bit word out or adding in a random string, that would change all the offsets, and that might ruin it beyond recognition, and you would miss bugs by doing that. So that's about as smart as we got, was taking some stuff out. Now, again, we did some additional stuff by hand, and we'll get to that. So if you perturb it too drastically, you'll end up with just noise instead of interesting noise. So what do we target? The attack surface is huge, as Alex said, and we have day jobs, and this was all done in between doing paid work for real clients. So this is, we just sort of did some stuff when we had a free week here and there. Here's a free day, let's do something. So we totally have not even really scratched the surface, the huge attack surface. So we just picked some of the most obvious targets: NTFS, FAT, ext2, obvious document types, obvious image types. Email databases are kind of interesting. for example, Exchange and Outlook Express are kind of tricky, whereas Thunderbird is just a big giant mbox file with a little index file that helps you find individual messages in it quicker. And one thing we noticed, and it makes perfect sense, is that the simpler formats tended to have less trouble. You know, FAT never really caused us any trouble in our fuzzing. Neither did Thunderbird's email database. Whereas things like PDF, doc, NTFS, it's pretty easy to make a mistake in programming a thing that understands those formats because they're horrendously complicated. And that's all part of the fun. So, and again, we didn't even touch weird things like Targa image files. Pick a weird format. There's a million. What if you used a funny file system? There's probably more bugs there. RiserFS, for example. Who knows? So that's a amusing area of future research. So, but we did get specific, as Alex said. You can, as a software developer, you can imagine what might go wrong when you're trying to read a partition table or when you're trying to read an MFT entry in an NTFS file system. So we tried to do specific things that seemed likely to work. So due to how our testing procedures were, we would make these fuzzy file systems or fuzzy files or fuzzy disk images and just feed them to the forensic tools in the normal acquisition process. And then the normal, if they survive the acquisition process, try to analyze the file system as you normally would and just keep doing it until you hit something and it makes it explode. In the case... That's the answer to that question is yes. One thing we did, and we'll get to that in future slides, there's a funny interaction between different implementations of these formats, like what does Windows believe NTFS is? What does one particular Linux driver think it is? What does Encase think it is? What does the sleuthkit think it is? And sometimes it's the case that a fuzzed disk image is useless in every situation, or that it causes crashes, or Linux won't mount it, or whatever. Other cases, Linux can handle it, or the sleuthkit can handle it, but one of the other things can't handle it. But there are some circumstances in which you can have an attacker can have a usable disk image, a usable disk, which Encase or the sleuthkit can't handle. And in particular, we've got a NTFS one, just like that. So yeah, and then one of the fun ones was the directory loop creation, and we'll show the specifics of that one later. But it's just again an obvious thing that could go wrong is how you're going to handle directory loops.
So when you talk about whether or not it's this is another kind of excuse that you'll see from the forensics vendors. Oh, that doesn't work, right? So when you talk about a file system, maybe if you're messing with something that's pretty key, like the MFT, then maybe that's true. But if it's something like I put an Exchange database that's corrupted on my machine, if I'm not running the Exchange server, I don't care. But a lot of these products in the default configuration, when you do an acquisition, it does what's called the signature analysis, in which it goes and finds all the data it can. The whole point of these products is to make it easy for you to find all the data, right? Then it will go and find every Exchange database and parse it, even if it's not an Exchange server. And so certainly if a forensic examiner turns off all the functionality, that won't be exposed. And so there's kind of a balance between putting things on there that are just there for when somebody comes around with forensic software that reads 300 file formats, and some of it that actually affects the working of the disk. There are also things like if I put multiple partitions, if I do loopback file systems, if I want to, some of these examples, it broke NTFS, but it worked in Linux. So if I want to hide my data and mess with people, then I just use NTFS with the NTFS3G driver in Linux. So it's kind of more complicated than just does it work or not. There's lots of different scenarios. I guess with most of these things, if you are a determined enough attacker, you can make it work for you. That's what I say.
Yeah.
Sorry.
So here's a couple more specific manual manglings we did. Just obvious stuff, long file names, directories with a million things in it. And one of those paid off, you'll see later. Deeply nested directories, what's it going to do? And again, you can create an image by hand that no operating system could handle, but that's not necessarily the relevant thing. It could just be a booby trap for an examiner. So the sleuthkit, It's a open source Unix-y forensics toolkit from Brian Carrier.
Is Brian here?
No.
Because he comes to BlackHat a lot. So.
Cool.
Okay, well, he's really cool. Is Brian here? No, he really is cool.
He's friendly. So it's in the Unix tradition. It has a million little programs that each do their one job, and it's up to the examiner to write shell scripts that put it together and pluck out things that are interesting to them. So it's more nerdy than for normal people, but it's quite nice. And so it's got 23 individual programs, and we found 4 of its tools had problems. And again, we just did this in our off hours, and there's probably more trouble laying in wait. But you can see here from the names and descriptions of the tools that each tool really does just do one thing. Like iCat, all you do is you tell it, here's a disk image, here's a number of an inode, or in the case of NTFS, an MFT entry. Please just look in this image and pull that one out and cat it. And then doing something with that is up to you, like feeding it to your PDF reader or whatever. iStat, again, it's like kind of like stat, only it works forensically on a disk image, and so on. So the sleuth kit is open source, which of course is wonderful. It allowed us to it gave us an easier time in testing, and specifically, we could actually fix problems that we found, or work around them quickly, and then do further testing. Because when you're blindly fuzzing like we did, you'll often hit a problem immediately that is really masking a deeper problem that also is present. So we were able to, in a couple cases, hit an instant problem and then close it off, and then find another problem that we found because we had now passed the first thing. So for that reason, testing and feeling good and verifying open source software is just super easier than closed source software. And we think that that has a serious security impact. Not that open source software is always better, or that it's even true that it's 1,000 eyes make bugs shallow or whatever. But in our case, we were able to take advantage of the benefits of open source to good effect. So here's the first bug. It should be probably immediately obvious to everyone here. It's pretty straightforward, and a fix is also obvious. But if you just feed a funny... Now, in the paper, I urge you to read the paper, you will see exactly what data object triggers this bug. It might be, I think it's from FLS, but the paper will tell you. So we have here, obviously, referencing data after we freed it, which, depending on your allocator, may cause trouble. And now here, another similar type of bug. Yeah. So here we made a corrupted NTFS image. And there's a lack of bounds checking here. It's trying to treat a 64-bit number as an offset. And it loops for probably not indefinitely, but that's a long time. Lots of Fs in the high order bits of that number. So we didn't wait a long time for that one to finish. And again, that's GDB with symbols, and that's just so great. So here's another one. Corrupted NTFS image makes iCat, the program that, like I said, will just print out the file